In this example, I'm asked to evaluate 1/10 plus 1/6 minus 1/45. And the way I'll do that is by following this three-step process again. The first step is to find the least common denominator, which is just the least common multiple of the denominators. So my denominators are 10, 6, and 45. And I can create my prime factorization trees. 10 is just 2 times 5. 6 is just 2 times 3. And 45, one way I could write that is it's 9 times 5, and 9 is 3 times 3. So what I get is that 45 is 3 squared times 5. And now that I have all the prime factorizations, I can find the least common multiple. In this case, the least common multiple is going to have 2's, 3's, and 5's. And so my task is to figure out how many of each of those I need. And the way you do that is you look at the highest exponent. In other words, we only have 1, 2 here, only 1, 2 here, and no 2's here. So just 1, 2 will suffice. We have no 3's here, 1 3 here, but 2 3's over here. So we'll need 2 3's in my least common multiple to make sure I have enough for any of these. And with 5's, we have 1 5 here, no 5's here, and 1 5 here. So I'll only need 1 5 to make sure I have enough for any of these numbers. And so my least common multiple is 2 times 3 squared times 5. In other words, 2 times 9 times 5, which is equal to 90. I can then move on to step 2. In step 2, what I want to do is rewrite this problem. It started out as 1/10 plus 1/6 minus 1/45. And I want to rewrite that in an equivalent form where all the denominators are equal to my least common denominator, which I decided was 90 over here. So the way I'll do that is to change 1/10 into a fraction that has 90 as the denominator. I'd have to multiply the top and the bottom by 9. Got to make sure I do it to the top and the bottom so I don't change the value of this fraction. Similarly, to change 6 into 90, you'll want to multiply the top and the bottom by 15. And to change 45 into 90, we'll multiply the top and the bottom by 2. So what I've now done is I've changed the original question into an equivalent question where I'm asked to add 9 90ths and 15 90ths and then subtract 2 90ths. And what's nice about this new form is that it's a problem I can deal with because it has common denominators. If I want to add and subtract fractions with common denominators, all I have to do is add or subtract the numerators. So I want 9 plus 15 minus 2, all divided by 90. And 9 plus 15 is 24, minus 2 is 22. So I get that this fraction is equal to 22 over 90. I should make sure that I should check to see if I can simplify this. To do so, I'll find the prime factorizations. 22 is 2 times 11, and 90, as I saw above here, is 2 times 3 times 3 times 5. So in fact, I can simplify this fraction. I have a 2 in the numerator that'll cancel with a 2 in the denominator. So what I'm left with for my final answer is 11 in the numerator and 3 times 3 times 5 in the denominator. 3 times 3 times 5 is equal to 45. So 1/10 plus 1/6 minus 1/45 is equal to 11/45. And this is my final answer.